friends, my name is Samiun Saad and welcome to my YouTube channel. Today I'm going to talk about product notation. So, product notation. Okay. So, product notation is basically this. It has like this kind of symbol and some variable j, some variable, okay? It's not some number like 2, 5 or anything like else. And then some constant number n and then m. And then a function f of j. J is the variable here. So basically this equals f of n times f of n minus 1 times n plus 1 times f of n plus 2 all the way to f of m, the number on top. This might seem like pretty complex, but it's actually very easy to understand. And one thing, summation notation, like this notation, will always grow much less than product notation. Because, summation notation is addition, but product notation is multiplication. And multiplication obviously grows much, much, much faster than addition. So, that's one thing covered. So, let's try some example problems. Okay. What is the product? Yes, the product from n equals 1 to 5 of pi n squared over n cubed e squared pi. Well, this is pi cubed. Okay, so you algebra students might see that many things can cancel out here. This n squared, this n cubed, this pi cubed, this pi. Yes, I know. But many people might argue that that's wrong because it's in the product. Like, basically this is in the form f of g of x, where f of x is a function of f and g of x is a function. But it still applies. So this is simply the product again from n equals 1 to 5. And by the way, this symbol is called capital pi. Many people have heard of pi before. This is pi, okay? But this is capital pi. It's in Greek. And in fact, pi is Greek as well. So this can cancel, leaving pi squared. So pi squared and cubed can cancel, leaving n on here. So pi squared over n e squared. Now, this is actually pretty simple. Like, this is pi squared over e squared times pi squared over 2e squared times pi squared over 3e squared times pi squared over 4e squared times pi squared over 5e squared. So it's basically like the same thing over and over again, except these just continue like that. Okay. Now this is pretty simple. Pi squared times pi squared times pi squared times pi squared times pi squared. What is that? That is 5 pi squareds multiplied together. And also that is simply pi squared to the power 5, and there is a rule of exponents. Well, to be honest, we, can't apply it here. Okay, so basically, there was this thing. So pi squared, what is pi squared? It's pi times pi. Now we're multiplying a bunch of pi squareds, which is pi times pi. So it's basically this. 2, 2, 2, 2, and there's another pair. How many pi's are here? There are 10 pi's. So it's just pi to the 10th. So the numerator is pi to the 10th over e squared times 2e squared times 3e squared times 4e squared times 5e squared. This number is pretty big. Pi to the 10th, very big number, over e squared times 2e squared is just well, 1e squared over times 2e squared, which is 3e squared. And then 2e, well, wait, where is it 2e squared? E squared times 2e squared is, wait, e squared times e squared. Wait. 2e squared times e squared is basically 2 times e times e times e times e. So basically the power of the e increases, not the 2. Like that does not increase. So basically it's 2 to the e to the 4th. 2e to the 4th. Got a little bit wrong there. 3e squared times 4e squared times 5e squared. Okay. 2e to the 4th times 3e squared. This is also pretty simple, as it is just pi to the 10th over, not going to make that mistaken, 6 pi, because 2 times 3 is 6. E squared times e to the 4th is e to the 6th. So 6e to the 6th times 4e squared times 5e squared. That's simple. Pi to the 10th. 6 times 4, 24 this time. 24e to the 12th. Well, not e to the 12th, e to the 8th. Times 5e squared. Which of course equals pi to the 10th over that 120 e to the 10th. Which is pretty big. So that is the solution to our problem. Pi to the 10th over 120 e to the 10th. So basically that's the solution to our problem. Let's continue on to another problem. Okay, so let's go to another problem. Let me actually erase this first. Pi's, all these e's, all these pi's, all these Euler's numbers. Also, if you don't know about Euler's number or pi, I'm going to write them down. Just for convenience of you guys. Here it goes. Here. Okay. Board is clean. Okay. So for convenience, I'm just gonna write the value of pi down. Pi is 3.141592653588979, etc. And E is 2.71828, etc. They go on for infinity. So, let's try another problem. Let's say the product. So, this capital pi again. Then we got J. I'll use J this time. J equals 1 to, let's say, 3. A smaller number. I'll just pick a smaller number of n squared. Oh, wait. Wait. I just got something wrong. And because it's not n squared, because J is the main variable, so it's actually J squared. This is a very, very, very important thing to keep in mind. Like you can't evaluate J equals 1 n squared of 3. You can't evaluate that to a finite value, because y is this here. Like it should be a J, because J is the main variable. But this is true, because, well, this could be written as n squared J over J. So basically, J over J, which equals n squared times n squared times n squared. Yes, but you could write it like that, so it's just n squared times the upper number. But that is pretty much kind of problematic, and you could write it like that. I don't know. Maybe if you want to. Calculate pi times 3, or n squared times 3. Okay, so J equals 1. 1 squared times 2 squared times 3 squared. What is 1 squared? 1 squared equals 1. 2 squared. 2 squared is 2 times 2, which equals 4. So 1 times 4 times 3 squared. 3 squared equals 3 times 3, which is 9. So 9. 1 times 4 times 9. 1 times 4 is 4. 4 times 9 equals 36. So the product from J equals 1 to 3 of J squared, and yes, that's how you say it, equals 36. And that is the final problem we'll try. So that's it for today's video. Make sure to comment, like, and subscribe, and also share this video with your family and friends. Bye bye.